Welcome to The Deep Dive. Today, we're charting a course into what a lot of people are calling the most transformative frontier in our economy right now. You hear it all the time, right? AI, chips, the next big revolution. But what if we told you it's maybe less like a fleeting trend and more like a modern-day gold rush? And here's the key idea for our deep dive today. In any gold rush, the real lasting money, it often isn't just with the prospectors digging for gold. They might strike it rich, maybe not. The consistent winners. They're the ones selling the shovels. The basic tools, the infrastructure that everyone needs, whether they find that huge gold vein or just end up with dust. So we are really going deep on that idea today. Our whole mission here is to basically decode this entire AI semiconductor world, the whole ecosystem, right from the ground up. We want to give you a genuine shortcut, a way to get really well informed on this topic, because honestly, it's absolutely crucial. And to guide us through this gold rush frontier, I'm joined by a fantastic expert, someone who's really spent years deep in tech innovation, market dynamics. Thanks for joining us on this really essential journey.
Well, it's great to be here. And you've absolutely nailed the analogy. It really is like a gold rush. This isn't just two technologies working together. It's a whole new ecosystem emerging, deeply connected. And it's fundamentally rewiring, I think, the global economy. Seeing this kind of foundational shift happen in real time, well, it's genuinely exciting. All the opportunities it opens up, it really does feel like that. But yeah, built on silicon, not gold nuggets.
Couldn't agree more. So let's start right at the very beginning. The bedrock, really. Because before we can even talk about the rush, we absolutely have to understand the tools themselves. For anyone listening who hears semiconductor thrown around all the time, but maybe isn't totally clear on what it means, could you break that down? In simple terms, what is a semiconductor? And why is it the basic material for these shovels in the AI gold rush?
Okay, yeah, let's strip away the jargon. Good idea. So basically, a semiconductor is a special kind of material, usually silicon, which interestingly comes from sand. Super abundant stuff. What makes it special is we can control exactly how well it conducts electricity, like very precisely. Think of it like a tiny, tiny electrical switch. Incredibly fast. It can either let electricity flow or can block it completely. Just depends on how we tweak it. And that control, that's everything. Now imagine billions of those switches, not just one. A modern chip, the brain in your phone or in those giant supercomputers is just a tiny piece of silicon, but it's packed, absolutely crammed with billions, literally billions of these microscopic switches. We call them transistors. The real magic, the marvel of the technology is how many of these engineers can cram onto a chip maybe the size of your fingernail. And the more transistors you can fit on there, the more complex math the chip can do. And crucially, the more things it can calculate at the same time. This whole process of making things smaller and denser, that's exactly why your phone today is just unbelievably more powerful than, say, computers from just a few decades back. It all comes down to these semiconductor chips. They're the foundation, literally.
Okay, so distilling that down, semiconductors are the actual building blocks. The raw material, almost, for anything we think of as smart or digital now. Our whole digital existence, phones, networks, everything, it hangs on these tiny switches.
Precisely, yeah. They're the bedrock. Couldn't have the digital age without them. And that connects us, naturally, directly to AI, artificial intelligence. Yeah. The link here is fundamental. See, AI models, especially the really powerful ones like the generative AI behind ChatGPT and similar large language models, they're designed to sort of mimic how a brain learns. And how do they learn? By processing just massive, truly staggering amounts of data. Imagine trying to read and understand, like, the entire internet all at once. To do that, these AI models don't just need speed. They need to do countless calculations in parallel. At the same time, that's the idea of parallel processing. Instead of doing task A, then task B, then task C, they do millions or even billions of things altogether concurrently.
Right, and this is where it gets really interesting, isn't it? Because that parallel processing thing, it sounds a lot like what graphics cards, GPUs, were already doing for video games. So GPUs, they were first built to handle all the complex 3D graphics, make games look realistic, right? And it turned out, almost by accident, that they were perfectly suited for AI's number-crunching needs. Is that why NVIDIA is just everywhere in AI discussions now? They were making gaming chips that happen to be the perfect AI shovels.
That's exactly it. That's the pivotal moment, the key insight. It was this remarkable, almost, accidental alignment. See, graphics processing units, GPUs, they excel at parallel processing. Their whole design, their architecture was built to handle calculating millions of pixels, textures, shapes, all in real time for a game screen. And that same basic structure turned out to be precisely what AI models needed for training on huge data sets and for running inferences, using the trained model. This lucky overlap, it kicked off this incredibly powerful feedback loop. And that loop is driving the whole ecosystem now. As AI gets smarter and bigger, it needs more and more compute power. Just insatiable. This pushes chip makers, especially leaders like NVIDIA, to innovate like crazy. Make faster, better, more efficient chips. And then those better chips, they let AI get even smarter, tackle even harder problems, do more things. And this isn't just theory, right? The money proves it. This direct demand from AI is the main reason the whole semiconductor market is projected to hit, what, something like $700 billion by the end of this year, 2025? It's a direct result of AI needing more and more power.
That makes total sense. So NVIDIA kind of lucked into pole position, designing these must-have shovels.
So,
But okay, designing a shovel is one thing. Someone still has to actually make it right and get it to the prospectors. So that leads us to the next part of the puzzle. You've called it the AI pipeline or the gold rush supply chain. Can you walk us through the next steps in this whole system? Who else is winning here? Who are the other absolutely essential players making money from this AI gold rush?
Absolutely. Yeah, it's a really detailed, intricate assembly line. Every single stage is not just important, it's critical. One part fails, the whole thing slows down. It starts, like you said, with the design. So let's call this step one, designing the shovels and pickaxes. And yeah, NVIDIA, they're sitting right at the top here, unquestionably. Their GPUs, especially the H100 and now the newer Blackwell series, they're seen as the gold standard, no question. And Blackwell, it's not just a small step up. It has this new transformer engine thing, really speeds up AI training, lets models get bigger, faster. It's a big deal. This tech advantage makes them pretty much indispensable for the biggest language models, the most advanced AI research. And because of that, they command something like, 80 to 90% of the AI data center market, which is huge. That kind of dominance in a market growing this fast. That's why you see their valuation soaring towards, what, $4 trillion now? Incredible. They are the clear leader, the top tool designer, setting the pace. But, they're not totally alone. There's competition. You've got AMD. They're like the scrappy challenger, but very capable.
they're MI300 GPUs. They offer a powerful alternative, maybe a bit more affordable. A solid pickaxe, let's say. And AMD's been doing particularly well, getting traction in inference.
Inference. That's using the AI after it's trained, right? Like asking ChatGPT a question.
Exactly. Training is teaching it, inference is using it, and AMD's offering a really strong option there for deploying AI cost effectively. So different tools for different jobs, kinda. And then there's another type of player, Broadcom. More specialized, but really important. See, the tech giants, Google, Meta, Amazon, they have these massive, unique AI needs. Sometimes even the best off-the-shelf GPU isn't perfect for their specific, huge-scale workloads. So they go to companies like Broadcom to get custom tools made. These are called ASICs, application-specific integrated circuits.
So custom chips just for them.
Pretty much. Built from the ground up, optimized for one client-specific, massive AI jobs. Often gives them unbeatable efficiency for that particular task.
Okay, so from an investment angle, you're saying there are opportunities kind of across the board here. You've got the leader, NVIDIA, the challenger, AMD, and then the custom guys like Broadcom. Lots of ways to play the design part. All right, so once these amazing chips are designed, what happens next? Who actually makes these incredibly complex things? Who builds them?
Right, that takes us neatly into step two, forging the tools and building machines. And here's a really important point. Companies like NVIDIA, AMD, they're geniuses at designing chips.
Yeah.
But they don't actually manufacture them, not the physical chips. They're fabless, as they say. They send their designs, their blueprints, the IP, to a super specialized factory called a foundry. And in this absolutely crucial part of the chain, there's one undisputed giant, the king, the main forge for advanced chips. That's TSMC, Taiwan Semiconductor Manufacturing Company. They're the main place, the most advanced place, where these complex designs become actual physical silicon chips. TSMC has the most cutting-edge factories, fabs, and they can etch circuits at scales that are almost hard to imagine, like 3 nanometers.
3 nanometers. How small is that, really?
It's incredibly small. It means packing something like 50 million transistors into a single square millimeter. Just staggering density. It boosts power, boosts efficiency, and honestly, only TSMC has really mastered doing that at the huge volumes needed right now. Pretty much every major chip designer relies on TSMC for their best stuff.
Wow. Okay, that really highlights something huge. TSMC isn't just a manufacturer then. They sound like a massive bottleneck, a critical choke point. Like, if something happened to TSMC geopolitics, a natural disaster, even just a big power cut, this whole AI gold rush could seriously slow down, couldn't it? Or even stop. I feel like the world's digital future kind of runs through their factories.
You've absolutely hit on something that, keeps a lot of people up at night. Their position is totally central, an unparalleled choke point in the global supply chain for the really advanced stuff. And it gets even more concentrated when you look at who builds their factories. To build and run those super advanced fabs that TSMC operates, you need incredibly specialized machines that are themselves engineering marvels. Which brings us to ASML, a Dutch company. And ASML has basically a total monopoly, a mind-blowing monopoly on the machines needed for the most advanced chip making. They're called EUV lithography machines, extreme ultraviolet.
EUV. What makes his machine so special?
Oh, they're unbelievable feats of engineering.
Yeah.
They use this process involving plasma from 10 droplets zapped by a laser 50,000 times a second, generates light at a tiny 13.5 nanometer wavelength, needs a vacuum, super precise mirrors, just insanely complex and expensive. Each one costs over $200 million. Took decades to develop. Bottom line, without ASML's machines, you simply cannot make the most advanced chips needed for cutting-edge AI. Full stop. Their uniqueness supports the entire top end of the chip industry. Okay, so the chips are designed, then they're forged by TSMC using ASML's machines. What next? They need fuel, right? AI systems are incredibly data hungry. They need to access and shuffle huge amounts of information really, really fast. That requires special memory, high bandwidth memory or HBM. And that's where a company like Micron comes in. They're a leader in
Oh,
HBM.
so it's just faster memory.
It's more than just fast, it's designed differently. It's stacked vertically, right next to the processor chip. This creates super short paths for data to travel, absolutely essential for AI models that are constantly moving massive amounts of data back and forth between memory and the processor super quickly. Cuts down on delays, bottlenecks. So think of Micron as supplying the high-octane fuel packs for these super-powered AI engines. Yeah. Keeps them running at top speed.
Man, this paints such a clear picture of how interconnected everything is. You've got the designers NVIDIA, AMD, the forge TSMC, the machine maker for the forge ASML, and the fuel supplier Micron. It really is a deep, complex, and actually highly concentrated web.
Wow. So, okay, the tools are designed, forged, fueled. Where does the actual mining happen? Where does all this AI number crunching and data processing physically take place? Where these operations run? Right. That brings us straight to step 3. Building the boomtowns and powering them. The places where all this massive computing work actually happens. Those are the boomtowns of this AI revolution data centers. And these aren't just, server closets. They're huge, sprawling, purpose-built facilities, often the size of several football fields. Packed, absolutely packed, with thousands and thousands of the most powerful GPUs, all engineered to handle the massive workloads of training and running AI models. These are the digital factories of our time. And within this space, you find companies like CoreWeave. They're kind of pure play here. They're basically digital landlords. They build these digital towns and then rent out plots of land servers packed with thousands of top NVIDIA GPUs all ready to go.
So companies rent computing power from them directly.
It's infrastructure as a service, focused purely on high-performance AI compute. Great for companies that need that power, but don't want the huge upfront cost of building their own data center. And it's worth noting, someone like Microsoft, a tech giant, is a major customer of CoreWeave. Shows you the demand. Then you also have players like Nebius Group, spun out from Yandex. They're busy building large-scale data centers across Europe, trying to meet the demand over there. So this boom is definitely global. But here's a critical point, something that maybe doesn't get enough attention yet, but it's becoming a massive issue. These AI boomtowns, they use an absolutely insane amount of energy, just staggering amounts. The computing needs are so intense that projections show data centers might need, get this, 165% more power by 2030 than they use today.
Wow, 165% more power just for data centers by 2030. That's astronomical.
It is. It creates a huge challenge, right, for sustainability, for grid stability, but it also creates a massive opportunity for companies who can help solve this energy problem.
Yeah, that sounds like a potential bottleneck for sure. A huge utility bill for these towns. So who's working on that challenge? Because efficiency and just plain power supply seem like the next big hurdle.
Oh, absolutely. And that's where you're seeing a whole new wave of innovation kicking off because it's desperately needed. You've got companies like Navitas, for instance. They attack the problem right at the component level. They make these hyper-efficient power semiconductors, gallium nitride, silicon carbide-based stuff, designed to drastically cut down energy waste, not just in data centers, but in electric vehicles, industrial power, lots of places. By making power conversion more efficient, they reduce the overall energy draw, helps these boomtowns run leaner, more sustainably. It's not just about cost, it's about enabling the scale without breaking the grid. And then there's the problem of keeping the lights on 24/7, especially with more renewables coming online, which can be intermittent. That's where companies like EOS Energy come in. They build next-gen batteries, but specifically for long-duration storage, not just short bursts, but hours of backup.
So keeping the power steady even if the sun isn't shining or the wind isn't blowing.
Exactly. vital for keeping these power-hungry AI hubs running non-stop. Smooths out the gaps, ensures stability. And beyond just power ships and batteries, people are working on advanced cooling too, like liquid cooling, which can be way more efficient than air cooling for dense GPU clusters. So, lots of angles to tackle the power issue.
So it's not just the digital real estate, the servers and GPUs, it's also the critical power infrastructure, the utilities keeping it all running. That's a fascinating extra layer, really shows the breadth of opportunities beyond just the chips.
Okay, we've gone from design to manufacturing to the physical towns and their huge power needs. What's the final step then? Once all this groundwork is laid, where's the actual gold? Where's the real value and application of AI being found? Who are the prospectors actually using this tech to create value? Slight pause. Right. That takes us to the final stage. Let's call it step 4. The prospectors finding the gold. This is where all that potential, all that compute power gets turned into real-world results, real value. So you have companies like Palantir, their Gotham platform. Think of them as selling really sophisticated maps and geological surveys for this digital frontier. They use AI to provide these deep analytics insights, helping big companies, governments, military units make sense of incredibly complex data, stuff scattered all over the place.
So they help find the valuable nuggets in the data.
Pretty much. Help identify hidden patterns, predict what might happen, get real intelligence out of just mountains of information. They show organizations where to dig for their own gold within their operations, turning data into strategy, optimizing supply chains, intelligence, you name it. And then, of course, there's one of the most visible prospectors out there, Tesla. They're fascinating because they're using AI across several different areas, really pushing the boundaries. Most people know them for self-driving cars, right? FSD, full self-driving, which is maybe one of the most ambitious AI projects anywhere. But they also use AI heavily to optimize their whole energy business, managing their supercharger network, optimizing grid-scale batteries. It really shows how versatile AI is. You can apply it in cars, in energy, simultaneously striking gold in different sectors, really demonstrating what AI can do in the physical world. And beyond those big names, you've got tons of others, startups, established players, building AI for healthcare like Tempest, using AI for personalized medicine, finance, logistics. Pretty much every industry is starting to see these prospectors emerge, using the foundational tech we talked about.
That is honestly the clearest walkthrough I think I've ever heard of this whole ecosystem. From the tiny chip level all the way up to global infrastructure and real world applications, it really connects the dots, shows how interdependent all these pieces are. Fantastic. Now, you mentioned earlier a kind of 4-phase roadmap for how this AI gold rush might play out, how it matures. Where exactly are we on that map right now? And, is this all real, tangible progress? Or is there still a chance it's just investor fever dreams driven by hype?
Yeah, that's a really important question. Where are we and is it real? And the answer is, I think, very definitively. It is very real. And we're right in the middle of a really critical transition point on that roadmap. So let's break down those 4 phases quickly. Phase 1 and phase 2, that's kind of where we are now. And they're absolutely in full swing, proven, solid. This is all about building the core tools, the chips, and building the boomtowns, the data centers to run them. And this part is absolutely proven. The demand is undeniable. Just look at NVIDIA's numbers, right? Revenue up 150% year over year. Why? Because everybody, big tech, cloud providers, startups, they're all rushing to buy these essential shovels. The need for basic compute power, it's established, market validated. This phase is the foundation for everything else, pouring the concrete. Now, phase 3, this is where we're seeing really rapid growth and emergence right now. This phase is about creating specialized platforms, vertical solutions for specific industries, not just general AI, but tools tailored for healthcare or finance or manufacturing. You mentioned Palantir for enterprise data, Tempest for healthcare. These are examples.
Using that base compute power to solve very specific complex industry problems. And this phase, this is crucial because this is where that raw power starts turning into bespoke solutions that unlock just tremendous value of different sectors. I really think this phase, the one we're entering now, is where truly exponential value gets created, AI moving beyond infrastructure into being a real agent of change within industries. And then finally, phase 4, that's still more on the horizon. The ultimate goal, maybe. This is widespread adoption, pervasive societal transformation driven by AI, where AI is just integrated into almost everything we do, often invisibly. Tesla's vision of fully autonomous cars everywhere, that's a phase 4 kind of vision, transforming transportation entirely. Or maybe AI revolutionizing energy grids, or dramatically speeding up scientific breakthroughs. That's the full integration, the ultimate impact across society.
Okay, so we're not right at the start, but we're well into building the foundations, and now the more specialized industry applications are really starting to take off. That feels like a really significant point to be at. Like the momentum momentum is really building.
Exactly. We are squarely in that crucial transition, moving strongly from phase 2 into phase 3. And this AI train, this whole thing, it's not just one piece of tech.
Good.
It's this complex ecosystem, right? Everything depends on everything else, and it feeds itself in this virtuous cycle. And the progress, it's undeniable. It's accelerating. AI models get updated like weekly now, sometimes faster. They get better. They need more power. And the demand for that compute power, it's not just growing steadily. The projections are for something like 1,000x increase by 2027.
1,000 times.
1,000 times. That's
Yeah.
the kind of exponential leap we're talking about.
Yeah.
So no, this isn't a dream. It's not just hype. This is very real progress, driven by incredibly strong fundamental demand for the tech.
I really appreciate that clarification. It helps put things in perspective past the initial buzz deep into serious building. So, okay, let's tackle the big one, the elephant in the room. The question I know is on every listener's mind, especially if they remember previous tech cycles. Is this an AI bubble? Is it going to pop? We all remember the dot-com crash, early 2000s. So many promising companies, even big ones, just vanished spectacularly. How is this AI boom different? Are we just setting ourselves up for the same thing again?
It's absolutely the right question to ask. And yeah, given history, it's a valid concern. But I think the crucial difference, the reason this is different, comes down to the nature of the spending, where the money is actually going. That's where it really diverges with the dot-com days. See, back in the dot-com bubble, a lot of the investment was purely speculative, pouring money into websites, online businesses. Many with no real revenue, maybe no real product, shaky business models. It was all about eyeballs, future potential, projections, very little concrete stuff, tangible assets or proven profitability backing up those crazy valuations. Value is based on clicks, not bricks and mortar, so to speak. This AI boom, it's fundamentally different. The spending is massive, yes, but it's going into foundational infrastructure. We're talking real, tangible, physical assets, cutting-edge chips, huge data centers, the incredibly complex machines needed to make the chips. The world's biggest, most established, most profitable companies, Microsoft, Meta, Google, Amazon, they aren't just playing around. They're investing tens of billions of dollars. Capital expenditure, CapEx.
Yeah.
Specifically for AI chips and the data centers to run them.
Tens of billions each.
Collectively, yes, massive amounts. This is real infrastructure being built out globally at an unprecedented speed and scale. They're literally putting concrete, steel, silicon in the ground, driven by a clear, immediate need for more compute power to stay competitive.
So the demand isn't just hyper speculation this time. It's backed by huge real investments from the biggest players. That feels like a key difference.
Exactly. And think about this too. Beyond the massive CapEx, look at the potential growth runway. Despite all the noise, all the breakthroughs, actual corporate adoption of AI, it's still incredibly low. Estimates are maybe only around 5% of corporations have really integrated AI meaningfully into their core operations yet.
Only 5%. Wow.
Yeah, that number alone tells you there's just a massive runway for future growth. For sustained demand, continued investment, the demand for these shovels and boomtowns, it's not peaking. It's accelerating because most of the global economy hasn't even started tapping into AI's potential yet. There's a whole world of efficiency gains, new products, new services waiting to be unlocked. Now, that being said, like any gold rush, there's always nuance, there's always risk. Some individual prospectors, specific AI application companies, yeah, they might fail. Just like in California, right? Not every miner struck gold. Some AI apps won't find a market, some will get outcompeted. That's normal. However,
Yeah.
the companies selling the essential tools,
Right.
building the infrastructure, the NVIDIAs, the TSMCs, the ASMLs, the CoreWeaves, they are positioned to succeed almost regardless. Why? Because everyone in this gold rush, whether they find their specific niche of gold or not, they all need those shovels, those pickaxes, those boomtowns. Their success isn't tied to one specific AI app hitting it big. It's built on the fundamental, accelerating demand for the tools themselves, tools needed by every single player. So my final take, it's clear, this isn't a speculative bubble like the dot-com era. This is a foundational shift in technology, a genuine revolution, driven by real demand, massive real investment, and just vast untapped potential. It's a transformation with deep economic roots.
That's a really powerful distinction, and it ties back perfectly to what we try to do here on the show. Equip you, our listener, with the insights to understand these huge economic shifts. This isn't just tech chatter. This is potentially your roadmap to understanding, maybe even participating in, the next wave of wealth creation. So let's just crystallize that investment thesis that comes out of this deep dive. Tying it back one last time to that gold rush analogy, you could consider investing in the tool designers. Think NVIDIA potential for explosive growth, given their dominance. Or AMD, the strong challenger, carving out its space. You could invest in the essential forgers and suppliers. These are the critical, almost irreplaceable players. TSMC, the manufacturing king. ASML, the monopoly machine maker. They represent arguably stability and a wide competitive moat. And don't forget crucial suppliers like Micron, with that vital HBM memory. Then there are the specialty suppliers, key niche players hitting specific needs, like Broadcom for custom networking and ASICs, or Navitas tackling that huge energy efficiency challenge. You could also look at the boomtown landlords and utilities. They're the ones building and powering the physical AI infrastructure. Companies like CoreWeave renting out that prime digital real estate, or EOS Energy working on the long-duration power storage critical for keeping things running. And finally, yes, you can bet on the savviest prospectors, the application leaders actually finding the gold, like Palantir selling those analytical maps, or Tesla leveraging AI across cars and energy. This has truly been a masterclass, decoding something so complex, so important. Thank you so much for breaking it all down with such incredible clarity.
Oh, it's been my genuine pleasure. It really is an exciting time, a transformative time, and the opportunities from people who understand these fundamental shifts, they're pretty immense.
Folks, navigating this changing economic world, understanding these deep shifts isn't just interesting, it's becoming essential for strategy, for foresight. This AI and semiconductor revolution, it's not just tech news, it is literally shaping the paths to economic opportunity for years, maybe decades to come. So dive in yourself. Take what you've heard today, do your own research on these companies, these trends, really empower your financial future with this knowledge. This is your chance to get a handle on what's truly driving value in the world today. Until next time, this is The Deep Dive signing off.